In this lecture, we want to explore the problems that might pop up if you pass rvalue references to functions or methods. And we will start by giving you a simple warning. If by any chance you assign a name to your rvalue, the rvalue is going to be treated by the compiler as an L-value. Because by design or by definition, an L-value is something that has a name and that you can grab the address of and use some kind of pointer or reference to manage it. So the moment something has a name in your C++ program, even if that happens to be an R-value, that's going to become an L-value, and you need to be careful about this. If you give a name to your L-value and try to pass it to functions or do whatever, you are going to be doing copy semantics. You want to be using move semantics that you would otherwise be wanting to use. Let's look at a few examples to really drive this home. We are going to set up a simple item class, and it is going to have a bunch of methods inside. We have a regular constructor, we have a copy constructor, we have a copy assignment operator, we have a move constructor here, and we have a move assignment operator. These guys are available, and we're going to see how this plays out with our C++ program if we do a few things in the main function. So suppose we have a getValue method which is going to return an item by value, and that's going to be a temporary object. So if we try and get this temporary and set up an rvalue reference to extend its life, and try to use this rvalue reference in an assignment like we do here, for example, one might expect this to call the move assignment operator. But this is going to call the copy assignment operator because this guy here is an L-value because it has a name. So the compiler is going to treat this as an L-value, and we will see the copy assignment operator called. And this might not be what we want. If you want to get the move assignment operator called, you need to pass this through an std move call. This is going to call your move assignment operator, and you will see it called. So again, if you take your rvalue and assign it a name in your C++ program, the rvalue is going to be treated as an L-value by the compiler. If you happen to use that rvalue either in constructors or assignment operators, and you want move semantics, please remember to insert this std move thing to force the compiler to treat that as an R-value. Otherwise, by default, it is going to be treated as an L-value, and you will have copy semantics. You need to be aware of this. We also get the same behavior if we pass R values to functions, and those R values happen to have names attached to them. Here we have a simple function to try and drive that home. We have a parameter passed by rvalue reference because we have two ampersand symbols here. And because this guy has a name here, the compiler is going to treat this as an L-value, even if what we pass in happens to be an R-value. Let's go down in main and try this out. We're going to set up an rvalue reference to item, which is what we have here. We will pass this to our function here, which takes an rvalue reference. But if we do this, we will get a compiler error, and the compiler will be complaining that what we are passing in is an L-value. And it is an L-value because this parameter has a name, so the compiler treats this as an L-value. If you want this to work with this function and avoid this compiler error, for example, you can insert your rvalue reference here into an std move and force the compiler to treat this as an R-value, and this is going to do what you would otherwise want. We also have the same situation, for example, in box container if we set up an add method which works on rvalue references. If we pass an R-value inside and try to do an assignment like this, we will see that this will call the copy assignment operator by default. Again, the reason is this R-value reference has a name here, and the compiler will treat it as an L-value, which will cause this assignment here to call the copy assignment operator. And this might not be what we wanted when we went through the trouble to make this guy an R-value reference. So if we want move semantics for this add method on this assignment here, we need to insert our thing into an std move. And this is going to force the compiler to treat this item here as an R-value, and we are going to steal from it. Now that you know these ideas, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is passing by rvalue reference. We will reuse the code from the last lecture, so let's grab everything. And we will put this in our current project. And we can open this little boy in Visual Studio Code by dragging and dropping here. This is going to give us our code. We have deleted the copy constructor and the copy assignment operator from the last lecture. In this lecture, we are going to bring them back. So let's remove the deletion here. We can go down and bring the copy assignment operator back. And once we do this, we need to go down and uncomment the implementations we had commented out in the last lecture. We can go down and also bring in the copy assignment operator. It is right here, so let's bring this back. And this is going to be a good starting point for what we want here. Let's go in main and try to do a few things. We can remove the populate method here, or function. We don't need this. We don't need a unique pointer here. So we can really remove everything we have in the main function. I think this is going to do. And I am going to put in my item class, which is exactly what we saw in the slides. So let's look at this. If you want, you can grab the code for this in the resources section on this lecture. You will have this class and you can use it like you want to really learn about the things we are exploring here. The item class is going to be wrapping an integer, and it is going to be using a pointer to manage that. In our constructors, we will allocate dynamic memory. You see we have new int here. This is our default constructor, which is going to allocate for new dynamic memory and not put anything useful in. We have another constructor, which is actually going to put in a value. And we have our copy constructor and copy assignment operator. And we have our move constructor and our move assignment operator here. You will see that the copy constructor is copying from the source object. So we will be copying from source. So we will set up a new dynamic memory location and copy data from the source object. You notice that we really are not stealing. The assignment operator is going to do the same thing. It is going to copy whatever data we had in the second parameter and use that as our data here. So we're going to steal the value and paste that in our pointer. If we go down and look at our move members, we will see that our move members are actually going to steal data. You see, we are stealing whatever pointer that we had in the source object. That's what we do here. And we need to do our invalidation. We will do the invalidation here right away. So we will reset the pointer in source to really play it safe. The move assignment operator is also going to do the same thing. We will steal the pointer and reset the data in our source object. And we will return the current object to support chaining for the move assignment operator here. This is our class and it is going to do what we want. Another thing we have in is a pair of stdcout statements to know which method was called to do whatever it is we want. And we will try and see what happens if we pass rvalue references to item, to functions, or methods, and we're going to see how this plays out. Another thing you should notice is that we have an output stream operator to be able to print item objects. We also have a get value method, which is going to return an item object by value, and this is going to return a temporary object. The first thing I am going to do is set up an rvalue reference to item explicitly. So this is going to be an rvalue reference, and we will initialize this with the get value function, which is going to return a temporary. So what we will have here is a temporary, and we are extending the lifetime of this temporary by assigning it to an rvalue reference. Now, some of you must be thinking, if we do something like this and say item and item1 and build an item object from our rvalue reference, some of you might expect this to call our move constructor. Let's try and build and see what is actually called. So we will run the task to build with our favorite compiler. The build is going to be good, so this is a good sign that the code is working. But if we bring up a terminal window and try to run our program, we will see that the copy constructor was called to copy data. And we passed in an rvalue reference. So what is going on here? Well, the rvalue reference actually has a name in our C++ program. And the moment anything has a name in your C++ program, the compiler is going to treat that as a null value. And if we try to construct from that, we will get copy semantics. We will really be copying from the L value. That's why this is calling the copy constructor. If we want this to call the move constructor, we can force the compiler to do that through an std move call. So we can say std move and pass this through our call here, and now this is going to call our move constructor as we would have wanted earlier. So let's try and build this again. We can pass this through our GCC compiler. The build is going to be good. We can clear and run rooster. Now this is going to call the move constructor and everything is working as we expect. So be careful. If you assign a name to your R value, it is going to be treated as an L value by the compiler. And if you happen to be constructing from that or assigning from that, you will get copy semantics and not move semantics. This is also the case if we happen to pass R value references to functions. So for example, if we go on top here and set up a function which is going to do something with an item, the parameter will be passed by R value reference as we have here. And some of you might expect this to do move semantics if we pass in our R value reference like this, but that's not going to be what you get. If we do an assignment in our function here, for example, and assign this item to another internal item, this will do copy semantics, because even if we passed in an R value, the compiler is going to treat this as an L value because this parameter has a name. So if we want this to work, we should really pass this through an std move call here, and this is going to do move semantics. We can go down and do that and try to use this function here, and we will go down and say do something and pass in our rvalue reference, and you will see that this is not even going to compile because what we pass in here is going to be treated as a null value by the compiler, but we don't have a function here that takes a null value. So this is going to blow up. This is going to give us a compiler error, and it won't work. Let's pass this through our compiler and see the compiler error for ourselves. You see the build finished with errors, and if we go down in our code, we will see that we can't bind an R value reference to a null value. So what the compiler is saying is, I expect to get an R value here, but what you are giving me in the call is a null value, and it is a null value because this guy has a name, and the name is the parameter name we have in our function parameter here. So this is what the compiler is going to do. If you want this to do move semantics and get the code to compile, you have no choice but to pass this through std move to force the compiler to treat this as an R value reference, even if it has a name. Okay, so the moment we do this, we might expect the line here to do a move assignment because we are really passing in a temporary object. Let's try and build and see what we get. We pass this through our compiler. Now the build is going to be good, but if we clear and run rooster, we will see that we are calling the copy constructor to copy data. Because on line 64 here, we are really constructing an object. So this is not going to call the copy assignment operator. This is going to call constructors because we are constructing this internal object here. That's why we see that the copy constructor is being called. But this is not doing move semantics either because this guy has a name even inside this function here. So we really aren't getting move semantics as we would have wanted. If we want move semantics, again, we have to pass this through std move, and we can do something like this. Now, this is going to do move semantics, and we will be stealing from this little guy that we passed as a parameter to this function here. You should really be careful. If you pass an R value reference to a function, be sure that whatever you are doing isn't really being disturbed by the names that you assign to your R value references. This is the message I am trying to convey here. Now, if we build our program, it should work and do move semantics for everything. The build is good. We can clear and run rooster. And what is wrong here? Seems we have a crash. And we don't have any data in our internal item that we have in our do something function. Let's try and investigate. We have this problem because we have already stolen from this rvalue reference at this location here, and we are trying to reuse it again at this location. So by the time we do what we do on line 79, rvalue ref really is a shell object. It doesn't contain anything. That's why we get a crash if we try to steal from it and print the data that we have stolen. Now, if we want this to work, we can comment out the line here. It has done its purpose. And if we build again, we will see that the code is going to work, hopefully. Let's clear and run rooster. Now we have the data inside, and we have stolen the 22 here from our rvalue reference, and everything is working exactly as we want. I want you to see that we can also do the same things and get the same behaviors for our box container class. So what I am going to do is add a move version for the add method. Let's go down and see if I can find it. I am going to add a copy of this and put in a version that does work with an rvalue reference, and this is the version here. We can go down and find our add method and change it a little bit to do move semantics. Let's see if I can find it. I have it right here, so I am going to put a copy of this down below to do move semantics, and it will take the parameter by rvalue reference. But down here where we do our copy, we want to make sure that we pass this guy in an std move, because otherwise here we will have copy semantics, because the rvalue reference here has a name, so the compiler will treat it as an L value. To play with this and show you the behaviors with this method, we can put in a bunch of stdcout statements. I think this is going to do well, and we can go down here and say, and let's see what we get. We can go in main and try to create a box container objects that is going to contain items. We can comment out what we had before, and we're going to create a box container containing item, and we're going to say items, and we're going to say items add, and we're going to say get item. What is the method called, or the function get value? This is going to give us our thing, so we're going to say get value here. And we will try and add an rvalue that we get from our get value function here. Let's see what we get. Some of you might expect to get the move version called. Let's see what we get. So we can pass this through our compiler. The build is good. Let's see what we get if we run this little boy. And we will see that the move version is called because this guy doesn't have a name yet. So it is an rvalue. But inside you see that we are calling the copy assignment operator because we are using a parameter name. So our rvalue did get a name from this parameter here. That's why we are calling the copy assignment operator. Because of this name, the compiler is treating this rvalue as an L value, and that's why we get the copy assignment operator called. But we did go through the trouble to set up a move version of the add item function because we wanted to get move semantics for any construction or any assignment we do. And here we are getting copy semantics, and we don't want that. To fix this, we can pass this guy through an std move as we have seen before. So we're going to do std move here. And this is going to cause for the move assignment operator here to be called, and we will get move semantics. You really need to be careful about this. Let's build and see what we get. So we can pass this through our GCC compiler. The build is going to be good. We can clear and run rooster. And now we will get the move version called, and we will call the copy assignment operator to copy data. And we see that we are still calling the copy assignment operator. What is going on here? Let's see what we are printing in our move assignment operator in our item class. So item move assignment operator, we are saying that we are moving stuff. So the problem is not here. What could be wrong? Let's go back to box container and see our add method and see if we don't have anything wrong with it. We have our add method here, and we have a const on the add method here. And the compiler is probably seeing that this is an rvalue reference and we can't go through this to modify our item when we steal from it. And it is choosing the copy version here. But if we remove the const, again, I am sorry for this, and go down and do the same in our implementation, we can find our add method and we have our move version here. I think that if we build now, this is going to be picked up by the compiler. And when we go down here, we will do a move as we want, and we will see a message saying that we have moved data here. We don't want to see item copy assignment. We want to see item move assignment operator called here. This is what we are after. So let's try to build our program again. Let's pass this through GCC. The build is good. Let's clear and run rooster. And now we are moving data and everything is working as we expect. The message here is that whenever you set up a move version for whatever it is you are doing, make sure that you pass the parameter as non-const, because putting in a const is going to confuse your compiler. This was a really good learning experience to have this problem here, and it gave me a chance to show you that these kinds of problems can really pop up when you don't expect. This is all I had to share in this lecture. Hopefully you know that whenever your rvalue reference has a name, you have to be careful and make sure you pass that through std move to get proper move semantics for your class. We are going to stop here in this lecture. In the next one, we will try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.